hope you are best and fine. Yes, you complete your attendance first. Within the already I am given time for you for the given attendance 9:40 to 9:45. You have to go with attendance only. Yeah, yesterday we already completed, students, about our Newton's second law and the linear momentum and the derivation part of our what is our derivation part of our Newton's second law. Yes. As in our textbook, according to the Principia, which is written by our Newton. Yes, the Newton's second law said for us as a statement actually what? Change of rate of momentum is directly proportional to force acting on the body. But directly we have taken that it is not understand for us, and for this purpose only activities are there. Already yesterday we have completed activity 1 and as well as activity 2. According to the activity 4 and 5, activity 4 and as well as the 5. According to activity 4 and 5, once we have taken the mass is remains constant and forces are changes, from that one will get for us what F is directly proportional to. From this activity, when you take the masses are same, okay. Yes, here also it is also contains somewhat 10 kgs, it is also contains somewhat 10 kgs, but here we are providing somewhat 10 newtons. Suppose we have to provide it is on, that is what we have considered somewhat, here take somewhat 5 newtons only. Okay, the mass is remains constant. At that time, that is the F is directly proportional to the acceleration. More force is given, otherwise the large force is given, greater in acceleration. Okay, this is the first equation we have written. And suppose you take the same thing here, the masses are changes somewhat, it is a 10 kg mass we are taking here. Another one you take here only just 5 kgs of mass, and forces are same here. There is a force F is only there, otherwise there is we are using the 10 newtons force. There is only I am using here. Here I am using again here also 10 newtons force. The force remains constant and the masses are changes automatically. It is acceleration is inversely proportional to the mass. Larger is the mass, smaller in acceleration. Got it? Larger is the mass, smaller in acceleration. I hope you are understood. Larger is the mass, smaller in acceleration. Okay? Yes? And larger in force, acceleration is also greater. Okay, that is only we have taken that is 2 equations. These 2 equations, once we combine these 2 equations, F is directly proportional to A, and as well as this is also written as based on acceleration, A is directly proportional to F, A is directly proportional to 1 by m or inversely proportional to m. A is directly proportional to 1 by m, or it is also called A is inversely proportional to m. Combine these 2 equations. Combine these 2 equations. We get what here? What we get for us? A is directly proportional to F into 1 by m, and it is also written as F by m. Okay, now it is also written as, when you go for m here, F is directly proportional to m into A. Okay, clear or not, all the students? And now it is also written as F is equal to taken as K into MA. Yes, K is a force constant. K is a force constant. K is a what here? K is a force constant. K is a force constant. Now automatically it is become F is equal to, yes, MA when K is equal to taken as 1. When K is equal to taken as 1. Okay, I hope you are understood. This F is equal to MA is only called what? Newton's second law. F is equal to MA is only called what? Newton's second law. This is the derivation of a second law. Okay, now from this only we have to go with our how our Newton is said. How our Newton is said. Yes, a change of rate of momentum is equal to force. Otherwise, the force is directly proportional to K is a force constant. K is a force constant. Yes, and the change of rate of this from this equation only we will get the what? This from this equation only we will get for what actually we get change of rate of momentum. Change of rate of momentum is directly proportional to force. Either in case K is equal to 1, it is also written as change of rate of momentum is equal to force. How? Okay, clear or not all of you? We go with the derivation for what? The derivation for change of rate of momentum. Change of rate of momentum acting on the body or coming in the body is equal to force. Okay. Yes, it is what this derivation is gives for information about product of mass and acceleration of a body is equal to force. Yes, it is in another way the change of rate of momentum is equal to force. Yeah, you take here first F is equal to MA. You take here F is equal to taken as MA. Clear or not all the students? F is equal to MA. Yes, now you know very well. A is equal to what? A is equal to acceleration is equal to what? Acceleration is equal to, anyone give the definition, what is acceleration? Change of rate of velocity. Change of rate of velocity is only called acceleration. Suppose you take for one body, yes, final velocity is a v, initial velocity is taken as u. Okay, now by time, that is only called what? Change of rate of velocity. Okay, clear or not all the students? I hope you clear. And here there is a what we consider a v minus u by t. It is called a. Here f is equal to taken as. F is equal to taken as. Now you substitute it in equation number 1. It is taken as equation number 2. Yes, write equation 2 in equation 1. In equation 1. What will we get for us? What will we get for us? F is equal to taken as m into v minus u by t. All the students, please respond to the already whatever the questions, whatever the topic are completed. Okay, and already you know very well what is acceleration, but only 2 or 3 members are right that answers. Remaining are also compulsory you mention your answer. Okay. Already yesterday I am explaining you why we are right like that. If you are go with the classes, if you are prepared or not, yes, if you prepared well, you may compulsory you mention your answer. Yes, and here there is a what m into v minus u by 2. Now you also written as it is. F is equal to also written as it is m into v minus m into u by t. Yes. Now here you know very well it is a what? Momentum or not? mv is taken as a final momentum. It is taken as what? Final momentum. M into v is what? M into v is the what? Momentum. The product of mass and velocity is called what? Momentum. It's a final velocity, na? That's why it is taken as final momentum. And after last, mu is taken as initial momentum. It is takes as a what? Initial momentum. It is a final momentum. It is a called initial momentum. It is a called initial momentum. Okay, clear or not, all the students? You substitute this value and this value in this equation. I hope you are understood. You substitute PF and PI in where? In this. F is equal to taken as now. It is also written as what? Nana? PF minus PI by T. By T. Okay, clear or not, all the students? Now there is a what? F is equal to also written as, this is indicate the what? This is indicate the what? Change of rate of velocity. This is indicate the what? Change of rate of momentum or not? Yeah, it is written as change of rate of momentum. Change of rate of momentum. Clear or not, all the students? F is equal to change of rate of momentum. Okay, if you take it is for a small interval of time, if you take it is for a small interval of a time, it is also may written as what? F is equal to dp by dt, dp by dt or del p by del t, del p by del t. Clear or not, all the students? It is an indicator what? PF minus PI is written as a del P or not? PF minus PI is written as a del P. Here there is a taken directly total time. Okay, now suppose the time at a final momentum is taken as a TF, and for initial momentum is taken as a TI. It is also written as the T may written as here del P. Okay, now for small interval. Automatically it is a become what? F is equal to written as F is equal to may be written as, yes, what it is? dp by dt is equal to del p by del t. dp by dt or del p by del t. In this way only we have to go to calculate our force, and our Newton says that what actually? Newton said that F is directly proportional to the yes, F is directly proportional to the which one? Change of rate of momentum. Change of rate of momentum. Okay, clear or not, all the students? Yes, and once again I want to go for explanation of this one. At that time you note it. Yes, once again I go with the explanation. Yeah, here what we are taken? A we are taken. You know very well. A is written as maybe, yes, del V by del T, del V by del T, or it is also written as Vf by Vi. Yes, Vf by Vi. This is indicate the what? Final velocity, or it is indicate the initial velocity. Okay, now at the final velocity at the t f time, it is taken as from what? T I time. Clear or not, all of you? Change of rate of velocity. It is written like this or not? Yeah, like this only we have to write here. Okay, now here it is also written as F is equal to taken as m into, okay, del V by del T, m into del V by del T. Returnable or what it is? It is a returnable. Okay, now it is also written as F is equal to also written as m is a constant or not here? M is a constant or not here? Yeah, m is remains constant here. M is constant. Then F is equal to written as del by del T of mv also. Okay, now here mv is not actually momentum. mv is a what? Momentum. It is equal to taken as p. You know very well. Momentum p. Now F is equal to become what? Del by del t of p. Del by del t of t. Yes. Now it is a become what? F is equal to. F is equal to what it is? F is equal to taken as del p by del t. Del p by del t. Okay. This is the way to derive our chemical equation from the which one? F is equal to Ma. How we will get F is equal to Ma? Already we are discussing. Clear or not, all the students? Here A is written like this. Okay, now, and as well as you substitute the A value. Yes, you substitute the A value. Now there is a what we have to written. Our equation 1 becomes. Now equation 1 becomes. Okay, now yes, F is equal to M into del V by del T, and here M is a constant. Why I am written M is a constant? M is a constant or not? Already I have given this information. M is a constant or not? Yeah, M is a constant. Mass is a universal constant. Mass is a what? Universal constant. It is not changes. Mass is a universal constant. It is a never changes. Then what is the changes? Weight is a changes. Which one is the changes? Weight is a changes. Weight changes with the gravitational force. Weight is changes with the gravitational force. Okay. Yes. Suppose your mass remains constant. Suppose the mass of the one man is made 60 kgs. Okay, but the weight is not become 60 kgs. Why? Because weight is equal to what? W is equal to taken as mg. W is equal to taken as mg. Okay, it is a what? Force only. It is also force only. Okay, now that force when the body is in a vertical motion, when the body is in a vertical motion like this, otherwise when the body is a flighted mode. Okay, clear not all of you? When the body is in a flighted mode, at that time it is not possible to apply our F is equal to ma. You should compulsory A is replaced with acceleration due to gravity. A is replaced with acceleration due to gravity. Yes, dear students, actually in our textbook they are given what? About acceleration due to gravity and about weight we have to go to discuss in our lesson gravitation. But unfortunately for this academic year, the gravitation lesson is removed from your syllabus. Removed from your syllabus. Okay now? For annual examinations. But compulsory we have to go to read and about our gravitation lesson for the project purpose and for the concepts purpose we have to go to read our gravitation lesson. Somewhat of your syllabus may deleted for your examinations purpose. All the 9th class student, it is a precious time for you, and as well as this much opportunity may not get for any of a 9th class batches. Okay, why? Because due to this lockdown of the schools, you got a lot of time. Okay, now for improving your knowledge in your 9th class only. And as well as may next academic year, yes, new education policy may introduced by our government. Okay, yes, there is a may not compulsory. Yes, and for this purpose only, yes, it's important to the year that 9th class is an important year for every student life. Why? Because from the 10th class onwards, you have somewhat targets. Now you not have that much of compulsory targets are not there. May it is till now we not get about any examination information, but the compulsory this time annual examination is there. Without the annual examination, like last year, it is not promoted to the next class. The promotion for the 9th class is a very important and it's a compulsory. That's why don't neglect. Tell to your friends who are not attend to the classes, who are not taken textbooks till now. Yes. About the school starting, we don't know. Now the school is started already. Why you feel the school is not started? It started from your home only. I am where actually? I am in the school only. You are not there in the school, but you are in the classroom now. You are in the classroom or not now? Why you feel the school is not open? Already school is open. School building is not open. Okay, now studies are open. Okay, now the classes are very important and analyze is very easy to you now. Yes, suppose in a classroom, may I am rough this, it is not available for you. But it is available now. When I am written, it is available for the up to 20 to 30 years. Whenever our YouTube is there, whenever our YouTube is works, yes, that our topic is there. Okay, clear or not all the students? Yeah, that's why don't feel that our school is not going on like that. Yeah, tomorrow I will provide to you about a physical science syllabus. Otherwise, once you consult to your principal sir or madam, just for examinations only, somewhat syllabus is reduced. Okay, now some examination purpose only. For our teaching classes, for our reading purpose, for the projects purpose, for the maintaining the notes purpose. Okay, now there is a no change. It is 100% of syllabus. We have to go to discuss only. Okay, clear? Yes. Just wait. Yeah. Okay. Students, and now we are completed. It is or not? All the students. We forgot about our Newton's second law. Yeah. What is the Newton's second law? Tell me. Anyone? Newton's second law? What is the Newton's second law? Yeah, Newton's second law said for us information about the momentum. Okay, now, yes, when you take a linearly, the law may be written like this: F is equal to ma. Okay, clear or not all of you? As when it is in a, yes, actually when it is in a vertical manner, suppose the body is not linear, it will be moves through the influence of a gravitational force. It is written as F is equal to mg. F is equal to written as mg. Okay, now when the body is in like this. When the body is in a travel like a chalk piece, like this chalk piece, at that time the body is taken as F is equal to mg. The force is acting on the body is taken as F is equal to mg. When you take a linear momentum, at that time it is written as F is equal to ma only. Our Newton's second law said about how much quantity contained by the body, how much quantity of force contained by the body, or otherwise how much force is applied on the body. That all the information came from our Newton's second law. Once check it out. First class said about why the body is not in a motion, when the body is coming into the motion, why the body is in a rest, when the body is coming into the rest. Yes, it is the first law. Second law said for us what? Yeah, second law of motion said for us how much quantity is required. How much quantity is required to move the body. Which one quantity? Force. How much force quantity is required yet to move the body? That is a very important to you. Yes, that is only the what difference between the first law and the second law. Okay, clear or not, all of you? Yeah, students. One more important part here. The second law gives the first law also. Students, listen carefully. Our second law gives the first law also. It proves the first law. How? It proves the first law. How? Okay, clear or not, all the students? Anyone have this idea? Yeah, once we have to go from the second law, we have to go to derive the first law. It is not there in our textbook. Okay, no, it is not there in our textbook. Please once consult with it. First law from second law. First law from second law. How we are taking first law from second law? It's a very important. And why? Because the first law is only contains statement. There is no mathematical proof for the first law till now. Na? Yeah, we take that these also. Okay. Suppose you take F is equal to MA. Na? Second law is what? Second law say for us F is equal to MA. Okay. And suppose F is equal to MA means what here? F is also written as M into V. Otherwise, it is also written as d by dt of M into V minus U by T. It is the second law we have to written. Yes. Now, if it is a what actually net forces. It is a what it is? Net force. F net. If F net is equal to 0. If F net is equal to 0. Means what we have to take it is 0. F net is equal to 0. Means what? Here this equation. This equation is a become what now? M into V minus U by T is equal to 0. Written or not it is? Yes? We substitute F net is equal to 0 in this equation 1. Okay now? Yes, we have taken as 2 here. From equation 1 and 2. From equation 1 and 2. Yes, it is a become what actually? M into V minus U by T is equal to 0. Yes, when this equation is satisfied, either may M is equal to 0 or may M is compulsory V minus U by T is equal to 0. Clear or not, all of you? Suppose when you take here, yes, X is equal to A into B. AB is equal to 0. When AB is equal to become 0? When AB is equal to become 0? Yes, either A is equal to 0 or B is equal to 0 or A is equal to 0 and B is equal to 0. This is only the mathematical condition or not? This is only the mathematical condition or not? When X is equal to taken as AB, either A equal to 0 or B equal to 0 or AB is equal to 0. Compulsory. Okay, in this way only, here either may M is equal to 0 or may V minus U by 2 is equal to 0. At that time only it is become 0. Clear or not, all this? Now, M is equal to become 0 according to our physics. Mass is become 0. There is any use of these all the things? We taken mass is equal to M is equal to 0 in our physics. No, it is not possible. M is never become 0. M is not equal to 0. Then what will we get? V minus u by t is equal to 0. V minus u by t is equal to 0. Clear or not all the students? V minus u by t is equal to 0. Then it is also written as V minus u by t is equal to 0. Here it is also written as V minus u is equal to 0. Yes, when it is a goes here, V minus u is equal to 0. Yes, here now V is equal to u. V is equal to what? U. V is equal to u. Okay, clear or not all of you? V is equal to u. What you understood from this? This is only called what? This is only called first law. What you concentrate on these two things? F net is equal to 0. V is equal to u. What it says? It says a first law. How? Once you combine two these things, what it is a combine? F net is equal to 0. V is equal to u. What it says? What it says actually? F net is equal to 0, V equal to u. When there is a net force is acting on the body is in equilibrium. Equilibrium is nothing but there is a final velocity. V is a what? Final velocity. U is a what? Initial velocity. Final velocity is equal to initial velocity, nothing but the body is under motion. Once again I am repeating it now. F net is equal to 0. Means what? There is a no force acting on the body. F net is equal to 0, nothing but then no force is acting on the body. Okay now, automatically initial velocity is equal to final velocity. Means what? There is a no force acting on the body. Yes, the body not changes its state. V is the final velocity, u is the initial velocity. Suppose V is equal to somewhat 40, u is equal to somewhat 40 meters per second. Here V is also become 40 meters per second only. Suppose u is equal to 0, V is also become 0. What the statement is given? When you take F net is equal to 0, V is equal to u. Means what? The 40 meters per second. Initial velocity is the 40 meters per second. Final velocity is also 40 meters per second only. Means what? It is continuous. It's a motion state only. When we not apply the force on the body, it's a continuous. It's a motion state only. Clear? And in case u is equal to 0. V is equal to also 0. U equal to 0, nothing but the body is in rest. If F net is equal to 0, V is equal to also 0. Final velocity is also 0. Means what? The body continues in rest position. It is which law? Is the first law or not? It came from where? It came from second law. Got it? I hope you got it. Yes, F is equal to ma is given the relation as V equal to u when F net is equal to 0. What you understood from this one? Okay now, when there is a net force is acting on the body is equal to 0, the final velocity is equal to initial velocity. Means what? The body is in a continuous, it's a original state only. Got it? This is only about our second law used now. Second law is also gives third laws. Okay. Second law is gives also Newton's third law. What is the Newton's third law? Every action is a contained reaction with the same magnitude but opposite in the direction. Every action is a contained same reaction. Okay, clear or not all of you? Yes, every action is a contained same reaction with opposite direction with the same magnitude. That is only called the Newton's third law. But from you, it is not applicable to you, all the students. Newton's third law is not applicable to you. You are not belonging to the Newton, you not follow the Newton's third law. Why? Because when I am asking the question, there is a not answer is getting from you. Every action is a compulsory contain the reaction. There is so many of the students are go with the irrelative matters. Somewhat say high area, somewhat say social distance. They not belonging to universal bodies. I hope. Why? Because they now follow the Newton's third law. Yeah, you should compulsory give the answer. Every action is a contain reaction with the same magnitude but opposite in the direction. Okay now? Yes, I am given the question to you. You should compulsory give the answer to me. Okay? Yeah. Here, I hope you are understood. I hope you understood or not this one. It's a very important. If possible, you note down. Yes. And lastly, you write here that information. If V is equal to 0, U is equal to 0. Because F net is equal to 0. Okay, clear or not all of you? F net is equal to 0. Yes. V equal to 0, U equal to 0. It is indicates there is no force acting on the body remains rest only. Yes, suppose U contains some value, U also contains the same value. U is equal to somewhat velocity is there, the same velocity contained for the V also. Okay, now when F net is equal to 0, there is a V and U also contain the what actually same values. Means what? It is a remains under the motion, it is a continue that motion. Yes, if F not equal to 0, here V not equal to, everywhere you have to take like is not equal to 2. Okay, now V not equal to U means F net is not equal to 0. Means what? Somewhat force is acting on the body. When the force is acting on the body not remains in a rest. In case it is V equal to 0, not U equal to 0. Okay, now if V equal to 40, may not it is U equal to 40. That is also. That is only called first law. Yes, the force is acting on the body. Yes, not equal to 0. F not equal to 0. Then the body changes its state. This is only the information about our Newton's second law. Clear or not, all students? I hope you clear. Yeah, one important note is there in our second law, below the second law. What is that? F is equal to ma is not applicable everywhere, but F is equal to dt by dt or del p by del t in this form. The both are same only, but it is applicable everywhere. It is applicable and everywhere. Okay, clear or not all of you? Everywhere only, everywhere. But it is not applicable everywhere. Why? Because the A is indicate linear acceleration. It is indicate what, Nana? Linear acceleration. Yes? And suppose you take a circular acceleration. Okay, clear or not all of you? When you take a rotatory acceleration. Okay, now otherwise you take one body, it is in a flight mode, means what? It is in the air. At that time the gravitational force is acting on it. Okay, that's why only there is about actually our force is F is equal to ma is may converted like this. F is equal to ma may converted as like mg. Okay, now why? Because the momentum is everywhere, may indicated by the P or otherwise may indicated by the L. Okay, clear or not all of you? Yes, another one, it is a torque. Torque means what? When you take a rotatory motion, at that time some force is acting on the body. That force is called torque. It is a having our think and discuss concept. When the fan is revolving, okay, and at that time also it is possible to take acceleration as same A. Okay, now yes, it is not correct actually. When you take a momentum, yes, in a circular bodies, it is a different from linear momentum. Already yesterday we have discussed. Okay, clear or not of the students? Yes, suppose one question I am giving for you. Your mass, maybe one of the body mass is 45 kg. Acceleration of the body. Homework question. Mass of the body is a 45 kg. Acceleration of the body it is somewhat 10 meter per second square. 10 meter per second square. What is the force? What is force? What is force? 45 kgs. Mass is taken 45 kgs. When it is linear, when it is linear, when it is linear, otherwise, one cricket ball traveled in this path, yeah, very good, 450 newtons. Second homework. One ball, cricket ball, contain one ball contain 1.2 kgs. 1.2 kgs. Sorry. It's travel some particular height. Okay now? Yes? What is force acting on it? Here I am giving hint for you. There is a F is equal to, you take mg here. Yes? G is our acceleration due to gravity. G takes here 9.8 meter per second square. Okay, clear or not all the students? You know very well, I thought when the body comes from some particular height, there is somewhat acceleration is working on it. That is only called acceleration due to gravity. Acceleration due to gravity. The value of acceleration due to gravity on Earth is 9.8 meter per second square. Okay. Yes, you have to calculate here what? Gravitational force. Okay. Bye. Take care. Complete these homeworks. Like these problems, you prepared yourself. Okay. Clear or not all the students?